aircraft propulsion. Okay, and this exam was 65% of GATE 2021. 65% of GATE 2021 was aircraft propulsion. Although it's not the necessary thing that it will always be such a thing. है ना? Okay, so the difference is that propulsion is mostly a theoretical subject. Okay, not the very much numerical. Right? But the numericals are also basically mostly formula types, and some questions are related to a little bit of conceptually questions. So, what is the syllabus of aircraft propulsion? How will we go forward? The first will be overview. Then second will be jet engine analysis, which is very important. Then our third, it will be compressor. After compressor, we will be mostly focusing on turbines. Then combustion chamber. Air intakes. Nozzles we have done, so we will not cover into this. Air intakes, and finally we will see rocket propulsion. Rocket propulsion, right? So, what will the topics will have? In overview, we will mostly have our normal, what kind of propulsions are there, then a little bit of classification. Paper in exam, these kind of questions are very much asked because I told you it's a theoretical subject. So classification, then what is thrust, what are efficiencies. After that, we will see about gas turbine cycles. Okay, in jet engine analysis, it will be all the engines which are like turbojet, turbofan. Then there's a case of afterburner case, something with afterburner, without afterburner, and then scramjet, scramjet, pulse jet, ramjet, scramjet, and efficiencies. These will be the topics of the jet engine analysis. In compressor, we will mostly see types of compressor like axial, centrifugal. Then we will see its characteristics. Sorry, characteristics. Okay, and then also I will be telling the velocity triangles. The same thing is important in turbines also. It's basically about work output. Here various other things are also there, but it's work output. Then we will be going to see degree of reaction. Then efficiency. In combustion chamber, we will see types of combustion chamber, structure of combustion chamber. Then the important thing is called equivalence ratio in here, right? Then it is pressure loss in combustion chamber. In air intakes, it is subsonic inlet and supersonic inlet. Nothing else. In rocket propulsion, there are various things, which is basically known as solid propulsion, liquid propulsion, and after that, hybrid propulsion. Then after it will be mostly related to rocket equation. So these will be basically all the topics that will be contained in aircraft propulsion, right? So today I will not take very much time of yours, and I will be just giving an intro of what propulsion is, because the first day should not be the overload. That I think that should be our case. So I will just tell you all the intros related to aircraft propulsion. What is the need of propulsion? How are the systems done? Okay. So first of all, what is need of a propulsion system? Need of a propulsion system. Second question is, can't we fly without engine? Third question is, we say that aircraft should be light. We say that aircraft should be light, but engine is heavy. Engine is heavy, and so is fuel. So is fuel. So how do we balance it? How do we balance it? So it's all of the case that is it really necessary to take up the propulsion system? Now, the answers are that propulsion system produces net thrust or forwarding force, which increases the speed of vehicle by accelerating it, and then due to pressure difference, we generate lift. And if we see only about aerodynamics, we can say that okay, when there will be pressure difference between upper wing and lower wing, there will be the lift generation. But lift cannot be generated without thrust. Suppose if you are not running, I mean there's a thing called in the childhood, people, small kids, they take a thing called firki in their hand and they run with that, and then only the firki rotates. Okay, you can generate power, you can generate something into a vehicle, into a particular thing, then only you can derive some output from it. So lift is kind of output of this energy that we are providing to this aircraft, and this aircraft energy is being provided by fuel. That's called propulsion system, and fuel is basically managed by propulsion system. Okay. Now about this weight light, so can't we fly without engine? No, we can't fly without engine. We can land without engine. Okay, that's called gliding. Okay, gliding is basically called power of glide. So basically it's not related to this. So requirement of propulsion system, we can say that engine should be small and lightweight. Now people think that the engine that they see in the aircraft, it's that much huge. Actually, it's not a huge, it's like a box. Whatever is inside is not very much complicated. It's basically empty space. And in compressor also it's empty space, in combustion chamber also empty space, in turbines and after turbine it's all about empty space. So it's basically a box, but that box is kind of propulsion system. So engine should be small, that's small and lightweight, and engine should give large thrust to weight ratio. Okay, engine should give large thrust to weight ratio, right? Now thrust to weight ratio means as compared to the weight, thrust should be always large. Suppose the aircraft is of 10,000 tons, so that is weight. So our thrust would be at least minimum should be the greater than 10,000 tons, and then only it's very much powerful. Third is basically engine should have low specific fuel consumption. Engine should have low specific fuel consumption. Low specific fuel consumption means that it should not use very fuel. It should use less fuel. Okay, so that's basically known as what we can say, low specific fuel consumption. And then vibration, pollution, noise should be minimum as possible. Vibration, pollution, and noise should be minimum as possible. Should be as minimum as possible. This is the case of the propulsion system. Okay. So now there are two ways to generate propulsion system. First is two ways of generating propulsion system. Propulsion system. The first way is propeller propulsion. Propeller propulsion. Propeller propulsion. Second is jet propulsion. So if you see propeller propulsion, it's basically that suppose this is the aircraft, and in the front of aircraft there's a kind of, like that, uh, a kind of this propeller is there. The propeller is there. Okay, and this propeller basically basically generates the propulsion system. So what we can say? We can say here that thrust is generated by propeller. Thrust is generated by propeller. Then second is engine is typically placed inside nose of aircraft which drives propeller, So in the flight mechanics, we have already studied the two types of engine: reciprocating engine and jet propulsion engine. So this kind of thing is basically known as reciprocating engine type. Reciprocating engine type, and this can be called as gas turbine engine type. Gas turbine engine type. That's why this generates brake horsepower and this generates normal power. And that this is basically suitable for low speeds. Suitable for low speeds. Wherever this propeller is there, it's always suitable for low speeds. Like turboprop is also there. So turboprop also is used for very less speed. So this is the basically engine, and from here to here, this nose is basically the power plant. That's called power plant actually. Nacelle, power plant. Various words are there. So here what happens is that all the air comes here, and all the air goes from here, right? So they kind of generate the forward thrust. That is called thrust. Now what will happen to the aircraft jet propulsion system? In jet propulsion system, we all know that it's something like this, and then it is something like that. I'm making very bad diagram, but still it is something like that. I'm just to make you a kind of view of how things is. I'm making this kind of way diagram. So it's like this. Yeah. So this is basically a kind of jet engine. In jet engine, what happens? Sorry. So here the air comes in. This is the engine system, and here it goes. Various differences. Okay, and this way it creates forward force, that is thrust. Okay, so this is the jet engine turbine system, gas turbine system. In this, what are the cases? So in this, it is thrust is developed by jet engine. Engine is driven by compressor combustor turbine unit. Compressor. Okay, let me write in next line. That's good. So engine is driven by compressor combustor turbine unit, and then it is high subsonic or supersonic, aircraft uses this type of unit. That is the basically called jet propulsion system. Right? So we use this kind of engines to go very much forward. So now the fundamental principle and everything we all know that of propulsion system. So we won't go into that much. inside. We won't go that much into the history and everything. I'm just giving you a small way of what is thrust. Okay, so what is thrust? Let me give you a direct definition. What is called the important definition in the propulsion system is basically thrust. So in thrust, we can say that according to Newton's law, F equal to m dot ue minus u plus pe minus pi into a. This is called thrust. Where now here what are the things? F is basically known as thrust. M dot, we all know m dot is basically known as mass flow rate. UE is basically known as exhaust velocity. U can be called as speed of aircraft or initial velocity. PE is basically known as exit pressure. PI is basically known as initial pressure or inlet pressure. Inlet is very good word. We call it inlet pressure. And A is basically kind of exit area, exit nozzle area. So this thing is basically known as momentum thrust. What is called? Momentum thrust. And this thing is basically known as pressure thrust. Pressure thrust. So if anyone will say that there is two things basically, one is called momentum thrust and other is called pressure thrust. Now many people have various types of question, various types of things they ask, like what is momentum thrust, what is pressure thrust, why is there a even component of pressure thrust? Is that necessary or not necessary? Something like that. So see, let me tell you a kind of definition using an engine. So an engine is basically, suppose this is a kind of, okay, that's very bad engine. Here also compressor is a little bit of highway, and this is the nozzle. This can be called an inlet, and I'm making the turbojet engine. And suppose this is the turbojet engine. So after some time, some way, there is this thing is known as compressor. This thing is basically known as compressor. Then here after some time it is called turbine. Okay. So compressor, turbine. This is called inlet. This is called nozzle, and maybe there is a chance that there is a afterburner. It's called afterburner. So what will happen actually is that air will come from speed u, and it will go out from speed ue. Okay. So see this thing that it is going from ue to u, velocity. Okay. So m into dv by dt, that is basically force. Okay. So actually, if you see the force here, so technically, if we see first, let me see all of things. First is basically we see momentum thrust. So momentum thrust, we can say that rate of change of momentum is force. Rate of change of momentum of aircraft equal to net thrust. So if rate of change of momentum, we can say mv. mv. So d by dt of mv is basically known as f. So we can say f equal to m dv by dt plus v dm by dt. There are two cases. M dv by dt plus v dm by dt. Now neglecting the change of mass of aircraft. Although it is changing due to the change of fuel, mass of aircraft is changing, but neglecting, we ignore dm by dt. So dm by dt is 0 basically. So we get m dv by dt. So we finally get f equal to m dv by dt. Okay. Now the second thing is this. difference in V. Okay, so difference in V is dV, but this dt is what? So this dt is basically how much mass flow is moving. Now mass flow rate and mass change is very different thing. And dm by dt is change of mass, but m by dt here it is. It's basically you can say that m divided by dt means change in time into dv. So dv is basically ue minus u, and this m by dt is basically known as m dot ue minus u. M dot means basically it's just due to time. It is this is m by dt is m dot, but actually mass is not changing. This is how much mass is entering. There are two things. One is how much mass of air is entering per unit time. That is called mass flow rate. And what is dm by dt? Dm by dt is that how much mass is reducing or increasing. So that's a different thing. So ue minus u, that is basically known as thrust. That is momentum thrust. Momentum. Now if you see pressure thrust. Pressure thrust. So actually momentum thrust is 90%, pressure thrust is only 10%. In the same aircraft, this you can say that PI, pressure inlet, and this is pressure out exit, PE. This is also AE, exit nozzle area. So we all know that pressure equal to force upon area. So force equal to pressure into area. That's why this formula came, that thrust equal to PE minus PI, that is change in pressure into exit area. And that's called pressure thrust. In total thrust, momentum thrust is basically is more than 75%, more than 75 to 80%, and rest is pressure thrust. Now, if nozzle is optimally expanded, we have studied this thing, an optimally expanded nozzle. Optimally expanded. What is optimally expanded? Optimally expanded means PE equal to PI. Then pressure thrust is 0. Thrust is 0. So these kind of things are basically more and more powerful. So in the formula of even thrust, so now let's only consider that F is m ue minus. Okay, so we won't be considering pressure thrust unless given. Now remember this line. We won't look for pressure thrust unless asked or given, right? So now the next thing is basically efficiencies. So there are three types of efficiencies. I've made a previous video also on that. So it's propulsive efficiency, thermal efficiency, and overall efficiency. In the case of propulsive efficiency, it is a measure of how effectively engine power is used, to power the aircraft, Now effectively means something you are giving and something someone is getting. So this is basically power delivered to aircraft upon output power of engine. This is known as eta P. Eta P means power delivered to engine. Engine to aircraft divided by output power of engine. So how much power engine is producing? Suppose engine is producing 100% power. So out of 100%, how much power is actually delivered to aircraft, and how much is lost? Kind of that thing you can say. That is basically propulsion efficiency. So if you see here, it is before this. Let me tell you a word called specific thrust. This thing called specific thrust. So F equal to M dot UE minus U, and F upon M dot, if you divide by, so thrust per unit mass flow rate, is basically known as F cap, and F cap is basically UE minus U. So F cap is basically known as specific thrust. So power delivered to aircraft formula is basically, power is what? Force into velocity. So force means thrust into aircraft speed, thrust into aircraft speed. And how to calculate the output power of engine? That means exit kinetic energy minus inlet kinetic energy. Okay. Exit kinetic energy minus inlet kinetic energy. So technically it is Fu divided by half Me UE square minus half Me, not Me, Mi U square. So U is basically exit and U is basically inlet. And if we talk about speed, then only U. Right? And assuming that there is no back pressure, huh? No back pressure, right? So that way pressure thrust is 0. So we can maintain this formula. That's basically known as eta P. This is propulsive efficiency. If we basically solve this a little bit more, it can be called eta P equal to F U. It was only thrust, so why we are using this specific thrust? We can only use this half Me UE square minus half Mi Ui square. Now mass is not changing, so we can say that here Me mass at exit. Me, what is Me? Basically Me or Mu, UE minus U into U divided by half Me, taking Me common, and it is UE square minus Ui square. Ui basically is U. Crossing Me and Me, it is basically 2 times UE minus U into U divided by UE minus square minus U square. UE minus U into U, UE minus U, and UE plus U. So it will be basically 2U by UE plus U. So it is eta P. Eta P is another formula is 2U upon UE plus U. If you more simplify this, then it will be 2 upon 1 plus UE by U. 1 plus UE by U. That is also a formula for eta P. And what does this formula say? One question was there in very previous gate. It was like how UE by U is. So UE by U increases, so propulsive efficiency decreases, something like that. This kind of question was. So this is basically known as propulsive efficiency. Then second is basically known as thermal efficiency. Thermal efficiency. Now this question was that how much power engine is getting out, and whatever engine is giving us power, based on that power, how much we are delivering to aircraft. Now thermal efficiency says that we are providing this much of fuel, that is as an input, and based on that input, how much power is actually producing by engine. Okay, it's a little bit of the next way game. So this is basically ratio of energy released by engine to energy available from fuel. Technically same way, saying in different words. It is basically known as eta T. T means thermal. So in thermal, what is the output? Output is basically half. This is Me UE square minus half Mi Ui square. This is whatever it is called the output. How much actually output is coming? How much input is giving? The input is M fuel. Now how much fuel is there into QR. QR is basically known as the calorific value of fuel. Calorific value of fuel. Mostly its formula is answer is 44 megajoule. Now, if you solve it, it will be mf. So this way it will be at exit. At exit now here we will since fuel is there, then we will not add here. So suppose how we will see this thing now. Okay, let me tell you here. Here it's that. Let's suppose this is the engine. So this whatever coming is this is basically mi. Then here it is compressor. Then combustion chamber, and then turbine. And in combustion chamber, we are giving the fuel which is known as MF or M fuel. So at the end, what is coming? ME. ME is basically MI plus MF. MI plus MF. So here we will use this formula. ME means MI plus MF. MI plus MF. And MI is basically kind of air. Air, mass of air, mass flow rate of air plus mass flow rate of fuel. Fuel to air ratio, that's called. So technically, it is MI is basically MA, mass flow rate of air, and MF by MA is basically fuel to air ratio, fuel to air ratio, and the opposite, that is MA by MF, is basically air to fuel ratio, air to fuel ratio. This is ratio is also very important. So here MI plus MF, and then UE square minus half MI UI square, right? So and then it is MF QR. So if you start solving it now, you will get finally that it can be take MIH common. So half take MIH common, so it will be called 1 plus MF by MI. MF by MI is basically known as F. Fuel to air ratio is basically known as F. So 1 plus F UE square minus here also UI square. Here also I'm taking MI outside. Divided by this is MF QR. So here MI will be coming out downside. So I'm removing this MI here and I'm making it downside. Okay, so here it is MF by MI. So this can be called as FQR. When you solve it, it will be eta T 1 by 2 1 plus F UE square minus UI square. What is UI? UI is basically U now. So use U square divided by FQR. FQ. Now we can take UE square also or something. Technically, this is also a correct answer. So you can say that thermal efficiency is 1 plus F UE square minus U square divided by 2FQR. 2FQR. This is called thermal efficiency. If we want to use now, we can solve this way. This formula also we can use. In propulsive efficiency also we can use the same formula. In propulsive efficiency also we can say, yeah, this thermal efficiency now. For propulsive efficiency in terms of fuel to air ratio F. Fuel to air ratio F. It is basically known as eta P ME UE minus U divided by same half ME UE MA U square. So if I wanted to convert here, ME can also be called as MA plus MF UE minus U divided by half, take half common, then take MA plus MF UE square minus MA U square, then take MA common, so it will be MA common, it will be 1 plus MF by MA, then it will be UE minus U divided by 1 by 2, take MA also outside now, 1 by 2, then MA, then here 1 plus MF by MA UE square minus U square. So this MA and MA cancel, this 2 will be going upper. Okay, so this 2 will be going upper, so it will be called as 2 times 1 plus F UE minus U divided by 1 plus F UE square minus U square. Now you can see that the denominator here is basically the numerator here. 1 plus F U square minus U square. Okay, I think some basically 1 plus F U square minus U square. So technically, if you see now, this thing will be cancelled. This is eta P. Now I'm using the same formula and you will be getting a great thing. So technically, the third efficiency is basically known as overall efficiency. Overall efficiency. Overall efficiency is basically eta P into eta T, that is thermal. So eta P formula I am taking from here, 2 1 plus F, 2 1 plus F, UE minus U divided by 1 plus F, U square minus U square. What is eta T? Eta T is basically 1 plus F U square minus U square upon 2F QR. 1 plus F U square minus U square divided by 2F QR. So we can say that this thing is basically cancelled. And what we are getting finally is eta O equal to this 2 and 2 is also cancelled. So it is 1 plus F UE minus U divided by F QR. Now this F and F can also be cancelled. It will basically 1 plus 1 by F. 1 plus 1 by F UE minus U by QR. That's basically known as overall efficiency. Okay. So these are the three important efficiencies which is very much used. Okay. So that will be it for today. In the next lecture, we will start the more advanced topics, and we'll start doing that. Okay. So thank you very much, and we'll see you tomorrow. Not tomorrow, Wednesday. We'll see you on Thursday, right? So on Thursday, 6:30, we will be starting this proportion from the here.